Materials, metals, and nonmetals. Learning about materials, metals, and nonmetals, their physical and chemical properties. There are various types of materials around us. Some are natural and some are man-made. In nature, metals are found both in free and combined states. The Earth's crust is the source of all metals. You are familiar with a number of materials like iron, aluminium, copper, etc. Metals shine in their pure state. This shining property of the metals is called metallic luster. Gold is yellow and copper is reddish brown. Aluminium, iron, and silver appear white. Metals are generally hard. Hardness of metals varies from one metal to another. Metals can be distinguished from non-metal on the basis of their physical and chemical properties. The luster and hardness are physical properties. Physical properties of metals and non-metals. Activity. Take a small iron nail, a coal piece, a piece of thick aluminium wire, and a pencil lead. Beat the iron nail with a hammer, but take care that you don't hurt yourself in this process. Try to hit hard. Hit hard also the aluminium wire. Then repeat the same kind of treatment on the coal piece and pencil lead. You saw that the shape of iron nail and the aluminium wire changed on beating. If they were beaten harder, this could be changed into sheets. We all are familiar with silver foil used for decorating sweets and the aluminium foil used for wrapping food. The property of metal by which they can be beaten into thin sheets is called malleability. Materials like coal and pencil lead do not show malleability. Can you hold a hot metallic pan which is without a plastic or a wooden handle and not get hurt? Perhaps not. Why? Plastic and wood are not good conductor of heat. You must have seen an electrician using his screwdriver. What kind of handle does it have? Why? Screwdriver has plastic handle because plastic is poor conductor of electricity. Iron rod, nail and copper wire are good conductors while rolled sulfur piece and coal piece are poor conductors. Metals are good conductor of heat. Aluminium and copper are used to make electrical wires. Have you seen wires of coal? Definitely not. The property of metal by which it can be drawn into wires is called ductility. Have you ever noticed the difference in sound on dropping an iron sheet, plate, a metal coin, and a piece of coal on the floor? The things made of metals produce ringing sound when struck hard. Since metals produce ringing sounds, they are said to be sonorous. The materials other than metals are not sonorous. Some materials are hard, lustrous, malleable, ductile, sonorous, and good conductor of heat and electricity. The materials which generally possesses these properties are called metals. The examples of metals are iron, copper, aluminium, calcium, magnesium, etc. Materials like coal and sulfur are soft and dull in appearance. They break down into powdery mass on tapping hammer. They are not sonorous and are poor conductor of heat and electricity. These materials are called nonmetals. The examples of nonmetals are sulfur, carbon, oxygen, phosphorus, etc. Information. Metals like sodium and potassium are soft and can be cut with a knife. Mercury is the only metal which is found in liquid state at room temperature. These are exceptions. Chemical properties of metals and nonmetals. Reaction with oxygen. The formation of magnesium hydroxide, which is an alkali, changes red litmus into blue. In general, metals from oxide, on combining with oxygen, water solution of these oxides are basic in nature. Activity. Hold a clean magnesium ribbon with a pair of tongs and heat it over the flame of a burner. What do you observe? Magnesium burns with a brilliant light and get converted into a white solid residue. Collect the solid residue left after burning of magnesium wire in a beaker or a glass tumbler. Add a little water to it and stir the mixture. The following chemical reaction occurs. Magnesium plus oxygen produces magnesium oxide. Magnesium oxide plus water produces magnesium hydroxide. Introduce a strip each of red and blue litmus paper into the solution. You will notice that blue litmus unaffected while the red litmus changes into blue, indicating that the solution is alkaline. Does copper wire also get rusted? I have seen a greenish deposit on the surface of copper vessels. When a copper vessel is exposed to moist air for a long time, it acquires a dull green coating. The green materials is a mixture of copper hydroxide and copper carbonate is formed on its surface. So copper can rust if exposed to moist air for a long time. Let us now observe the reactions of non-metals with oxygen. Activity. Take a small amount of powdered sulfur in a deflagrating spoon and heat it. Deflagrating spoon is not available. You may take a metallic cap of any bottle and wrap a metallic wire around it and give it a shape of a spoon. As soon as sulfur starts burning, introduce the spoon into a glass jar, glass tumbler, cover the tumbler with a lid to ensure that the gas produced does not escape. Remove the spoon after some time. In the reaction of sulfur and oxygen, sulfur dioxide gas is formed. Add a small quantity of water into the tumbler and quickly replace the lid. Shake the tumbler well. When sulfur dioxide is dissolved in water, sulfurous acid is formed. Check the solution with red and blue litmus papers. The sulfurous acid turns blue litmus paper red. This change indicates that the solution is acidic in nature. Generally, oxides of nonmetals are acidic in nature. Reaction with water. Let us see how metals and nonmetals react with water. Sodium metal is very reactive. It reacts vigorously with oxygen and water. A lot of heat is generated in the reaction. It is therefore stored in kerosene. Activity. During demonstration, special care should be taken that the size of sodium metal piece is roughly the size of a wheat grain. It should be held with a pair of tongs. Take a 250 ml beaker, glass tumbler, fill half of it with water. Now carefully cut a small piece of sodium metal. Dry it using filter paper and place it in the trough. You will observe that metals start moving in water with a hissing sound. Soon the metal piece catches fire. The chemical reaction between sodium and water produces hydrogen. A lot of heat is liberated in this reaction. As a result, hydrogen and metal catch fire. The reaction between sodium and water can be expressed by the following equation. Sodium plus water produces hydrogen. You observe that sodium reacts vigorously with water. Some other metals do not so. For example, iron reacts with water slowly. Generally, non-metals do not react with water, though they may be very reactive in air. Such non-metals are stored in water. For example, phosphorus is a very reactive non-metal. It catches fire if exposed to air. To prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. Reactions with acid. Let us see How metals and non-metals behave with acids. Collect a few small pieces of aluminium, copper and iron. Put a piece of each metal in a separate test tube and add to it about 10 ml of dilute hydrochloric acid. If no reaction occurs, warm the test tube gently, pointing its mouth away from your face. Observe the reaction carefully. Test the gas being evolved in each case by bringing a glowing incense stick near the mouth of the test tube. You will find that in all cases except copper, it burns with a pop sound, indicating that the evolved gas is high. The reaction of hydrochloric acid with aluminum and iron are shown in the following chemical reaction. Aluminum plus hydrochloric acid produces hydrogen gas. Iron plus hydrochloric acid produces hydrogen gas. You must have found that non-metals generally do not react with gas being evolved in each acid, but metals react with acid and produce hydrogen gas that burns with a pop sound. You must have noticed that copper does not react with dilute hydrochloric acid, even on heating, but it reacts with sulfuric acid. Reactions with bases. Activity. During the preparation of sodium hydroxide solution, care should be taken that pellets of sodium hydroxide are handled with a plastic spatula. Prepare a fresh solution of sodium hydroxide in a test tube by dissolving 3-4 pellets of it in 5 ml of water. Drop a piece of aluminum foil into it. Bring a burning matchstick near the mouth of the test tube. Observe carefully. What does the pop sound indicates? As before, the pop sound indicates the presence of hydrogen gas. Metals react with sodium hydroxide to produce hydrogen gas. Reactions of non-metal with bases are complex. Displacement reactions. We have seen that metals displace hydrogen from acids. Metals also can be displace another metal, as can be seen from the following activity. Activity. Take about 50 ml of water in a 100 ml beaker and dissolve 5 gram of copper sulfate in it. Add a few clean iron nails to the solution and keep the beaker undisturbed for some time. You will observe that the blue color of the solution starts fading gradually. At the same time, iron nails get a shiny coating of red-brown copper metal on their surfaces. This change takes place as iron displaces copper from copper sulfate. Copper separated from its compound forms a coating on the iron nail. This chemical reaction of this displacement process can be shown as follows. Iron nail plus copper sulfate produces iron sulfate plus copper turnings. A similar reaction will be observed if you repeat this experiment with strip of magnesium and zinc. In each case, you will find that a red-brown coating of copper forms on the strips of metal, magnesium or zinc. It means that like iron, magnesium and zinc also replaces copper from copper sulfate solution. Iron, magnesium and zinc are thus more reactive than copper. Magnesium plus copper sulfate produces magnesium sulfate plus copper turnings. Zinc plus copper sulfate produces zinc sulfate plus copper turnings. Thus, a more reactive metal displaces a less reactive metal from its compound in aqueous solution. Uses of metal and non-metals. Metals are used in everyday life for a variety of purposes. They are strong, hard and rigid, so they are used in making machinery. The automobiles, the aeroplanes, the trains, satellites, industrial gadgets are all use metals in large amounts. Iron is the most commonly used metal. It is used for making an object as small as pin or nail. On the other hand, it is used in making big gadgets and in reinforced concrete in conjunction with cement to construct big buildings. Aluminium is another metal that is widely used. It finds used in making household items. Aluminium is also used in making aeroplanes as its density is low as compared to other metals. Metals are good conductors of heat. Hence, they are used in making cooking utensils and water boilers. Metals like iron, copper, and aluminium are used for these purposes. The most important use of copper is in electrical gadgets. It is also used for household wiring. Nowadays, aluminium wire is used for making electrical cables because it is much cheaper than copper. Gold and silver are used to provide fine electrical contacts in computers and solar cells. Gold and silver are widely used for making jewelry. Highly reflecting mirrors are made of silver since it reflects about 90% of light falling on it. Non-metals, on the other hand, have dull appearance and generally are not good reflectors of light. Information. In a chemical reaction, new substances are formed. These substances are different from those which underwent the reaction. Now, if a substance cannot be broken down further by chemical reactions, by cooling, heating, or by electrolysis, it is called element. Sulfur is an element. So is iron. Carbon too is an element. The smallest unit of an element is atom. The atom of an element remains unaffected by physical changes in the element. For example, an atom of liquid sulfur would be exactly the same as an atom of solid or vapor sulfur. There are no more than 92 naturally occurring elements. An important classification of element is in terms of metals and non-metals. Most of the elements are metals. Less than 20 are non-metals. A few are metalloids, which possess characters of both metals and non-metals. Summary. Metals are lustrous, whereas non-metals have no luster. Generally, metals are malleable and ductile and are good conductor of heat and electricity. Non-metals do not have these properties. On burning, metals react with oxygen to produce metal oxides which are basic in nature. Non-metals react with oxygen to produce non-metallic oxides which are acidic in nature. Some metals react with water to produce metal hydroxide and hydrogen gas. Generally, non-metals do not react with water. Metals react with acid and produce metal salts and hydrogen gas. Generally, non-metals do not react with acids. Some metals react with bases to produce hydrogen gas. Metals and non-metals are used widely in everyday life.